Right, so welcome to my second segment. So we are looking at this is part 2 of my differentiation as I continue with some sample question and give you some more ideas. So it says find dy over dx for the function. So they want us to find the derivative or the gradient for the function. So the first one there says y is equal to 2x raised to the power 3 minus 3x squared plus 1. So remember what we said, if we have been given a polynomial, you differentiate separately. So then you find the sum of differentiating each term separately. So according to our rule, if you still remember, if you have y is equal to ax raised to the power n, to find dy over dx, we did say you multiply the index by the coefficient, so it will become na. Then what happens to the power? The power reduces by 1. So n minus 1, that's the way we find. So you do for each term. Then we did say if you have got y is equal to k, where this k is a constant, any number, if you want to find dy over dx for any number, it is just 0, so you don't need to waste time. So let's try to do here. So it is 3 times 2 will give you a 6, but remember that 3 reduces by 1. Again, it is 2 times 3, that gives me a 6, and that reduces by 1, so 2 minus 1. Plus a constant is just a 0, so it will be 6x raised to the power 2 minus 6x. That's 2 minus 1, so we don't write it. It's a 1 here, but I won't just write it there. Yeah, I won't write it there. Remember, you can actually ignore it because it's just 1. So this is actually the derivative or the differential coefficient, as we call it, for the function that we were given. All right. Let's look at the second one there. So the second one there says that find the gradient of the curve that at the point. So now they want us to find the gradient of this curve at the point where they have given us the coordinate, point 2,6. So what you do to find the gradient for the curve at the point they have given you, you first of all need to find the derivative of this function. So number 2 says that y is equal to x to the power 3 plus 7x minus 2. So first of all, what you do, find dy over dx. What is dy over dx? So remember, 3 times, what number is in front there? It's 1. So 3 times 1 is a 3, then x. That one reduces by 1, so 3 minus 1 will give you a 2. Minus, remember what, sorry, plus. I told you if you have got a number and a letter, you're just going to remain with the number. A constant will always give you a 0. Well, let me go back on that one. 7x. Remember, what that simply means is that there's a 1 here. So 1 times 7 will give you 7. But that power reduces by 1, so it will be 7. 1 minus 1 is a 0. Now, according to the laws of indices, anything raised to the power 0, so x raised to the power 0 is a 1. So 7 times 1 will give you what? 7. And that's why I'm remaining with that. So therefore, when we reduce this one, it will be 3x squared plus 7. So that is what we mean. So our dy over dx is equal to 3x squared plus 7. Now the question wants you to find the gradient at this point they have given you. So at the point 2,16. Now that point they have given you, after finding the gradient, since they have given you the point 2,16, the value of x is simply 2 and the value of y is 16. So they are telling you in simple terms that when your x now is a 2, what is the gradient? So we replace there. It will be 3 multiplied by 2 raised to the power 2 plus 7. So remember, 2 raised to the power 2 is a 4. 4 times 3 is a 12 plus 7. That is going to give us a 19. So our gradient at that particular point is simply, a 19. That is what, we are having there. So basically, you can deal it in that way. So first of all, find the derivative. So after finding the derivative, dy over dx, replace the value of x in this derivative. That gives you the gradient at a particular point in this case when our x is equal to 2. All right, so that is the way you can go about it. There's another question that I have this side. It simply says that find the points on the curve. Find the points on the curve y is equal to x to the power 3 minus 3x squared minus 6 squared minus 10, where the gradient is a 3. So they want you to find the points on the curve where the gradient is a 3. So what do we do to find that one? Again, you need to find the derivative. So find dy over dx. That's the first step that you need to do. So remember, if you differentiate that, 3 times 1 will give you 3, so x, and the power reduces by 1, so it will be a 2. 2 times 3, that will give me a 6, the power reduces by 1, so 2 minus 1 will give me a 1, but I will not write it. If you have a number and a letter, I told you that will just give you, in that case, the number. And the constant is always a 0, so it will be minus 0. But of course, this is the same as 3x squared minus 6x minus 6, because we ignore that one. So after finding the derivative, dy over dx, since they told us that if the gradient, is 3, it simply means that dy over dx, when you find it, it is equal to what? To 3. So this whole term that we have there, I will equate it to 3. So that is to say 3x squared minus 6x minus 6 is equal to 3. That's what we mean. Dy over dx, which we found is that should be equal to 3. We can read